Lesson 5-2, solving quadratic equations by graphing. We already know how to graph a quadratic function, and we know that the shape of the graph is a parabola. So to solve quadratic equations by graphing, we're going to be graphing parabolas and looking for specific points on the graph that represent the solutions. So here's standard form for a quadratic equation. The key thing really to remember here is that the equation has to be set equal to 0 if you want to solve by graphing. So you've got ax squared, the quadratic term, plus bx, the linear term, plus c, your constant term, equals 0. That's standard form. To solve a quadratic equation by graphing, what you're going to do is find the zeros of the function. New vocab there. Finding the zeros of the function basically means figure out where the graph crosses the x-axis. Okay, so roots or zeros, kind of different ways to just say the solution to the quadratic equation. Really on the graph, what they are is the x-intercept. So there are three possibilities when you graph a parabola, and this goes for U-shaped parabolas or the upside down parabolas as well. There could be one solution, and that happens when the vertex touches the x-axis, like in this first case here. So the vertex is on the x-axis, that means there's only one point where the graph is 0. Or there could be two solutions. I think that's pretty obvious. If the graph intersects the x-axis or 0 in two spots, you've got two solutions because these are the x values where the function is equal to 0. Or sometimes the parabola will never cross the x-axis like in this last graph, and that means that there's no solution. Let's try this example. So we want to solve x squared plus 6x plus 8 equals 0 by graphing. So the question is, what are the x values here that would make this equation, this side of the equation, equal to 0? So on the graph, it's going to be on the x-axis because that's when the y values are 0. So let's go ahead and set up a table of values. I always start by figuring out the axis of symmetry. I want to know where the center of this graph is, and I also want to know where the vertex is. So reviewing that formula, it's negative b over 2 times a. And in this case, b is 6. So I've got negative 6 over 2 times a. A is 1, so 2 times 1. And we get negative 6 over 2 or negative 3. Okay, so my axis of symmetry is at negative 3, this vertical line here. And that's helpful because now when I make a table of values, I'm going to choose negative 5, negative 4, negative 3, negative 2, negative 1. And hopefully that'll give me the solution somewhere in there. Okay, so here are my x values, negative 5, negative 4, negative 3, negative 2, negative 1, and negative 3 should be the x value for my vertex. That's the center of the graph. So let's start by plugging in negative 5. If I plug in negative 5 and squared, I'm going to get 25. Plus 6 times negative 5, that's plus negative 30, so I'm at negative 5. Then I'm going to add 8, we get 3, positive 3. If I plug in negative 4, I'm going to get 16 minus 24 plus 8. I'm plugging in negative 4 here, so I'll get positive 16 minus 24 plus 8. And that puts me at 0, doesn't it? Now, plugging in negative 3, I'm going to get, let me erase this up here. Plugging in negative 3, I'm going to end up with 9. Negative 3 squared is positive 9. 6 times negative 3 is negative 18. And then I'm adding 8. And I'm going to get negative 1. Now remember that parabolas are perfectly symmetrical, and so if I know that my vertex is at negative 3, negative 1, I'm guessing that the next y value will be 0. Let's check it out. Negative 2 squared, that's 4. 6 times negative 2 is negative 12. And then I'm adding 8, and I do in fact get 0. And if I plug in negative 1, I should get 3. My table should be symmetrical around the center point, which the center of my graph or the vertex is negative 3, negative 1. Okay, so let's graph this. And we've got negative 5, 3, negative 4, 0, negative 3, negative 1, negative 2, 0, negative 1, 3. So here's my parabola, connecting as neatly as I can here. And this is going to increase forever. Okay, so the two solutions here were the x values that made this side of the equation equal to 0. And there's two solutions, two of them worked. You can see them in the table. -4 and -2 are the two zeros of this function. So wherever you find your parabola crossing the x-axis, easy to see on the graph here, those are your two solutions. So the solutions to this equation are x equals -4 and x equals -2. And remember, with parabolas and quadratic equations, a lot of the times you are going to end up with two solutions. Let me show you one more. So this equation says 4x minus 1 equals x squared. First step, first thing I need to do is set it equal to 0. So I'm going to go ahead and do some math over here. 4x minus 1 equals x squared. All I need to do really is just subtract x squared on each side, and then I'll have it set up equal to 0. Okay, so I want to rewrite this carefully here. My quadratic term is negative x squared. That tells me my graph is going to be upside down because I've got a negative x squared, plus 4x minus 1 equals 0. So now I've got it set equal to 0. Next thing I should do is figure out where the axis of symmetry is so that I can make an accurate table and know where exactly the center of my graph is. So that formula was negative b is 4 here, over 2 times a is -1, a is the number in front of x squared, and what I get is -4 over -2, which becomes +2. So the axis of symmetry is at +2. So that means I want to choose 0, 1, 2, 3, 4 for a solid 5 points there. Okay, so in my table, I want 2 to be the center or the vertex here, so I'm going to pick 0, 1. 2 will be in the middle, and then I'll pick 3 and 4, and I'll plug these values in so that I get an accurate graph, accurate parabola. So if I plug in 0, I'm looking at this equation right here now. If I plug in 0, I'm going to end up with -1. If I plug in 1, +1, I'm going to end up with -1 plus 4 minus 1, and I get 2. If I plug in 2, I'm going to end up with -4 plus 8 minus 1, and I'll get 3. If I plug in 3, I should get 2, and if I plug in 4, I should get -1. Because remember, I did this step at the beginning to figure out where my axis of symmetry is, so I know that in the table 2, 3 is the vertex or the center, and I should have symmetry in the y values. Okay, so kind of have an issue here. I'm not exactly sure where the zeros are going to be, but I can see that my y values change from -1 to +2 here, in between 0 and 1. So I know that the 0 is somewhere in between these values because it switched from negative to positive. The other solution is going to be down here in between 3 and 4 because, again, I've switched from a positive number to a negative number. So let's just graph it and see what happens. 0, -1, 1, 2, 2, 3. And remember, because x squared was negative, I know that my graph's going to be upside down. 3, 2, and 4, -1. And so this time I can't tell for sure where the solutions are. I'm going to show you on the graphing calculator how we can figure this out for sure. But for right now, what you're going to have to do is just kind of guesstimate. So you can maybe say that the solution is close to 1/4 or close to 3.75, whatever. I think your textbook is going to ask you to say which x values the solutions are in between. So if I wanted to write my answer, I could say that the solutions are between 0 and 1, and there's another solution between 3 and 4. And again, you can see that on the graph here between 0 and 1 and 3 and 4. You can also see it on the table because whenever it switches from a negative to a positive, you know at some point in there it crossed 0. All right, so I've given you a couple examples here. The first one, we got exact solutions, and in this case we didn't get exact solutions from the graph, but you can say that the solutions are in between 0 and 1 and 3 and 4, and I'm going to show you how to get a decimal approximation for these answers using your graphing calculator tomorrow in class. Okay, so try this one, check for understanding here. I want you to solve by graphing, see what the parabola looks like, and figure out where the zeros are. In other words, where does the graph touch or cross the x-axis?